Okay, so we're going to talk about periodic phenomena. And so a periodic relationship between two variables occurs when the output values demonstrate a repeated pattern over successive equal length intervals. I know you guys are tired of hearing about equal length intervals, but that interval that is talking about where the length of the pattern is called the period. And so the period of a periodic function is the length of x values it takes to complete one cycle. And so we're looking at this f of x graph. Can you see what the cycle is? What's being repeated? I hope so.
4.
The period is going to be 4. Yes, nice job. So that is the pattern that repeats. And it takes it 4 x values to repeat it. And then it does tell you in the example that f is a function, a periodic function with a period of 4. And we have 2 periods graphed. We're going to graph an additional 2 periods. Can you guys do that? Super fun. Okay, now another thing we're going to do is take a periodic function like example 2, and we are going to evaluate it for x values that you can't see. So it's going to keep on repeating this pattern over and over and over again. So we can find like g of 72 even if 72 isn't on the graph that you see. So first thing we need to do is example 2 and figure out the least possible value of the period. So we can start anywhere. I'm just going to start at 0 because that makes it a little easier. All right, so that's the pattern I'm going to repeat over and over and over again, forward and backward. What is the length of that period? Yes, ma'am. Okay, and so on example 3, we're going to use the idea of this periodic phenomenon where it's going to keep on repeating that period or that cycle, and we're going to find g of 14. So 14 is not here, but I can use one of those numbers from -2 to 9 and add a multiple of 5 because the period was 5. Add a multiple of the period to it to get 14. Sorry, I didn't finish the sentence. We could do 9. We could do 9 plus 5. I did 4 plus 10. They're going to give us the same answer. So I just took a value from the table and I added a period to it. So just like g of 1 is the same as g of 6 because you add 5 to it, and g of 3 is the same as g of 8 because we add 5 to it, we can just drop off that multiple of the period. So g of 14 is going to be the exact same as g of 9. And what is g of 9? 7. Okay, so we can even go all the way to 72. So we're going to take a number from our graph, an x from our graph, and add a multiple of 5 to it to get 72. What do y'all think? 2 plus 70? Is that what y'all said? Because that's what I did, but I can't hear. Let's do that. 2 plus 70. That's actually going to be 14 periods we're adding to it. But it doesn't matter how many. It's going to be the same. G of 72 is going to be exactly the same value as G of 2, which is 6. All right, so you guys try to see on your own. It's not going to be a little more difficult. You're obviously going to have to subtract a multiple of 5, multiple of the period, to get negative 17. So 17 is 3 minus 20. It could also be other things, but it's going to be the same as g of 3, which is 7. All right, any questions on that? Okay, I'm going to go ahead and warn you that some of the ones on your assignment are a little more difficult than this. So some of them, like your x-axis is in multiples of pi. And that's to kind of get you a little bit a head start on what's coming up. It's doable. You're fine. I don't know why you're being so dramatic today. All right, let's look at example 4. We can do the same thing we just did with a table. Obviously, they'll have to tell you what the period is. And Brian Passwater chose a period of 5 again, which is a little bit easier than some of the ones you have to do on your assignment. Okay, so what I need to do is choose an x value from the table and either add or subtract a multiple of 5 to it to get negative 2. 3 minus 5. So that means h of negative 2 is the exact same y value as h of 3, which is just going to be 0. All right, you guys try to be on your own, please. Now C and D are a little more complicated. So for C, we have a composition, but we can still do it. We're just going to kind of have to do it twice. So we want h of 9. Now 9 is not a number up here, but I can take a number up there and add a multiple of the period to it and get 9. What number? Yeah. All right, so the outside h is just going to hang on. I can drop off the period part and find h of 4, which is 3. All right. And then before you start like trying to add 5 or multiples of 5, just look here. 3 is there. So h of 3 is just 0. That's just normal math. All right, and then for D, we want to find h of 5k minus 3, where k is an integer. So that 5k, where k is an integer, that's just a kind of fancy way of having a multiple of 5. And a multiple of 5 is the period that we keep adding. So h of 5k minus 3 would just be the same as h of what? Negative 3. We can just drop off that multiple of 5. Now, unfortunately, negative 3 isn't in our table, but we can just keep doing what we've been doing. Choose a number that is in the table and add or subtract a multiple of 5 to it to get negative 3. I think I heard somebody say it, 7 minus 10. And then h of 7 is just 2. Okay. So I feel like this kind of uses a different part of your brain, like a problem-solving part of your brain to figure this out. Right. Now we can use some notation to model this phenomena. So the periodic function starts with a basic pattern, and then it's translated horizontally over and over and over again. So for example, if we look at this first one, this is the pattern. If I take that and I shift it 4 to the right, it's that. If I take this one and I shift it 8 to the right, it's that. So it's a horizontal shift that shifts on top of itself over and over and over again. And so you can represent that horizontal shift in that the original function is also equal to that function shifted whatever the period is, to the right or to the left. All right, you could also say that h of x is equal to h of x plus or minus, I'm going to say plus, 5 times k, where k is an integer. So you can shift it any multiple of 5, either left or right, and it shifts on top of itself. They're the same exact function. Okay. All right, and then this very last one, the graph of f is periodic with a domain of all real numbers. 2 full periods of f are shown. Find the input values of f, find all of them, that yield an output of 1. So what is the period of this function? Yep. That is 1 cycle, and that is completed in 4 x units. Okay, and so from that first period, what x value, we want to know what x values give you a output of 1. So what x value in that first period gives you 1? Yes. All right, but we're going to just keep getting that cycle over and over and over again, to the left, to the right. We want to represent all of the x values that are going to give us 1. And so we can use kind of this idea that we were just talking about. So f of 2 plus whatever the period is times k, 4k, is going to give you 1, as long as k is an integer. So if k was a fraction, it wouldn't work. Because when you multiply 4 by 1/2, it's not gonna work. But as long as k is an integer, that represents all of the x values. There's an infinite number of them. That represents all of them. That will give you 1 as an output. Okay, the very last thing we're going to do is look at the first time. Well, maybe we looked at this a tiny bit at the very beginning of the school year. I forgot we did that this year. So like maybe day 1, you guys kind of saw something like this, and we answered questions about if the graph was positive or negative or increasing or decreasing. We're going to do more with it now. This is free response question 3, which was the one that my students last year did the absolute best on. Like we'll practice this so many times. You're going to be so good at it. Have no doubt. Like I think overall, like out of the 6 points, I think my students averaged 5 out of the 6 points on this question, and that's way better than they did on the other ones, especially free response 4. But anyway, this is going to be a contextual situation every single time. And what the first thing you're asked to do is find the ordered pairs of these 5 points that are going to be on the graph that results from the situation. So let's look at it. For example 6, the figure shows a large clock mounted on a vertical wall. The clock has an 8-inch long moving minute hand. So I'm just going to go ahead and label that. inches. The center of the clock is 120 inches directly above the floor. So from the center to the floor is 120. Now, each one of these questions will give you all the information you need, but it's not always the same information. So you just have to kind of like draw. I always draw, label stuff until I can figure out what I need to know. All right, so at time t equals 0 minutes, the minute hand is pointed directly up at the 12, like this clock is pointed up at the 12. However, the clock is not working properly, and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points at the 12 is at the time t equals 30 minutes. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically increases and decreases. So it starts off farthest away from the floor, and then it gets closer, 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 until it's closest to the floor, and then it starts getting farther and farther away again. All right, so the periodic function h models the distance in inches between the endpoint of the minute hand from the floor, the input, the minute hand from the floor, and the floor as a function of time. I think I left out some words there, but it's a function of time in minutes. All right, so the graph of h and its dashed midline for 2 full cycles for these 5 points are labeled on the graph. We're going to determine the ordered pairs for each of these. So I always start off with the heights, all right? So I know that from here to here is 120, and then I know this minute hand is 8. So I know also when the minute hand points at the 3 and the 9, that's the middle point, and that is going to be 120 inches. So we would label this middle 120. Does that make sense? Not really? Okay, so this point right here is when it's the farthest away. This is when it's pointing at the 3 and the 9, so it's halfway. And then when it's pointing at 6, it's the closest. So, okay, what's the farthest away it's going to be? 128. All right, so you can start with 128 if you want to. And these always have to be equally spaced. So from here to here is the same distance as it is from here to here. All right, and so the farthest away is 128. The halfway is 120. Does that make sense? All right, and then what about pointing at the 6? What's that going to be? Yes, good job. So on these 5 points, we've already figured out the y-coordinate. All right, so F is going to be 128. G is 120. J is 112, and then it goes back up.
Oh, never mind. I thought it said 118 on the head. I was confused.
Oh, sorry. I squeezed it in there. Okay, now for some people, that is the most difficult part of this. And sometimes the wording does get kind of weird, but you can't count on it being always the same. But you are always given everything you need. Sometimes it's more difficult to figure it out. All right, and then now we have to figure out the times when it reaches those certain heights. And so F is going to be when it's the farthest away. And so luckily on this question, it tells us at time t equals 0 is when it's pointed at the 12. So this is actually going to be at time 0. How long does it take it to do one cycle where it's back at the 12?
30.
Yeah, so P is also going to be at the max, which is going to be at time 30. That's the period. That's how long this weird minute hand it takes. What about J? Yeah, so that's going to be halfway. Yep. And then what about G? Yeah, so halfway between 0 and 15. Anytime you want to find halfway between two numbers, you just add them together and divide by 2. You find their average. Some of you can do that in your head like nobody's business. Some people struggle a little bit more. What about halfway between 15 and 30? Yeah. Now another thing that is helpful is that these increments are also equally spaced. And so to go from 0 to 7.5, that's going to be the same as going from 15 to the next one. And so if you can't do that in your head, because some people, numbers just like fly, you can take that 15 and add 7.5 to it to get your 22.5. That's fine. Or you can add them together and divide by 2. Okay, so let's put in those values for the input. And we have our 5 points. Okay. All right, so A is always worded exactly like that. And on your free response booklet, there's going to be a blank one of these with like blanks for you to fill in on every single one. It's going to look exactly the same. What changes is the situation. All right, B is going to have the exact same wording. The only thing that changes is these could change. So this particular one, we're going from G to J. It could be from F to G, or it could be from K to P. It could be any of those. But we are going to go from G to J to answer both questions here. Right? These questions are completely separate. You don't use the same thought process to answer B. I'm sorry, to answer, this should be I, to answer I as you do II. They're totally different. All right, so the first one, I or 1, is asking about what the graph, like the actual graph. Is the actual graph positive here? Is the actual graph increasing or decreasing here? So what makes a function positive? No, concave has nothing to do with it, but I'm glad you said that. It's because other people were thinking it too.
Is it the x value?
Not the x, you're close though. It's above the x-axis, it's the y value. Now on a normal graph, when you can actually see the x-axis, you just think above the x-axis. On our graph, there are going to be no axes. And so when a graph is positive, a function is positive, the y values are positive. And vice versa. I'm not going to write it here. When a function is negative, the y values are negative. So what do you guys think about this one? Positive or negative? All right, so it's definitely going to be either A or B. And then we need to just look at the graph and just look at what it's actually doing. At that section, is the function increasing or decreasing? Decreasing. So it's B. Decreasing means the graph is falling. All right, so we're decreasing here, 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 here. All right, and then number 2 is always going to ask you what the rate of change is doing, how the rate of change is changing. So when you're talking about how the rate of change is changing, what are you looking at? Concavity. So we're still talking about that same section. So how would you say the rate of change is changing in that section? You could say that. That's way more than you have to. All you have to say, I mean, that's beautiful, but all you have to say is increasing because the graph is concave up. And you don't even have to say why. So when I went to grade the test, my roommate actually graded this question, and all they're looking for is increasing. So I have someone in my second period that doesn't like to write, and I'm like, all you have to write is increasing. You don't have to say why. But if you say more than just increasing, quote the problem. The rate, don't say the graph is increasing, because that's not true. The graph is decreasing. So if you're going to say more, say, quote the problem. The rate of change of h is increasing over that interval. The reason is because the graph is concave up, but you don't have to tell them that. All right. Bless you. What questions do you guys have? All right.